Hello everyone, welcome back to the channel. Let's try to solve this problem. Now in this question we are given that 1 mole of ideal gas is there which is subjected to two reversible processes AB and BC. Basically this question belongs to thermodynamics topic and it's a graphical based question, right? So we are given a graph between pressure and temperature. At point A, B and C, both x and y coordinates are given to us, right? That is temperature and pressure. Also one point is given in the question that pressure at point A is equal to pressure at point C. That means AC is what? Isobaric process, we can say. Few statements are given to us, A, B, C, and D. We need to find which of the following is correct. So basically, it's a multi-correct question, right? Now, n is equal to 1 is given to us. That is, 1 mole is there for the ideal gas. We can do one thing. We can find the volume at each and every point in this process. That is at point A, B, and C. Because we know if PV is equal to nRT, and since n is equal to 1, that V is equal to RT by P, right? Now volume at A is equal to RTA upon PA. TA is given out to be 100 Kelvin and PA is given out to be 1 atmosphere. So VA is equal to 100 R. When we come to volume B, volume at point B, the temperature at point B is given out to be 600 R. 600, right? Temperature at B is 600 Kelvin and pressure is 3 atmosphere. So the volume will come out to be 200 R, right? Volume at B is 200 R. Volume at C is equal to RTC upon PC. Now TC is 300 Kelvin and pressure is 1 atmosphere. So VC is equal to 300 R. So that's how we find the volume at point A, B and C. Now let's go through the points options. First option is work involved in the path AB is 0. Now basically we know if we have to find work which equals 0, in that case delta V has to be 0. So basically there are few situations when the work is 0. Either it is isochoric process, when either it is isochoric process. In the isochoric process, what happens? Delta V is 0, so work done is equal to 0. Why? Because we know work done basically equal to minus P external dV, right? And in the isochoric process, change in volume is 0, so work done is 0. That is one state. That is one case where work done is 0. Second case where the work done can be 0 is when P external is 0. And the situation when P external is 0 is for the free expansion of gas. Free expansion means when there is no external pressure over the gas and the gas expands freely, basically in vacuum. So these are the two states when work done calculated can be 0. Since here VA and VB both are not equal, so delta VAB is not 0. That means work done involved in the path AB is 0 is incorrect statement. First statement is incorrect. Second statement, in the path AB, the work done will be on the gas by the surrounding. Now, since if you see from A to B, if you see the volume is expanding, the gas is expanding, right? Because volume at B is 200 R and volume at A is 100 R. So whenever the gas expands, that means the work is done by the gas because it's a expansion work, not the compression work. So during the expansion work, basically work is done by the gas on the surrounding. But here the option B is given reversed. So option B is also incorrect. At option C, volume of gas at C equals 3 times volume of gas at A. Now if you compare the VA and VC, VC is 3 times VA as it given here in the solution. So that means option C is correct. And option D, volume of gas at point B is 16.42 liters. Let's try to find it. VB is given to us as 200 R, right? We have already calculated it. So, and since the pressure is given in the terms of atmosphere, we use the value of R equals 1 by 12. So it is 200 upon 12, which will come out to be how much? Let's say we solve it, it is 100 by 6, or further if we solve it further, it will be 50 upon 3. So 50 upon 3 is equal to 16.48 liters, right? So approximately it is also correct. The volume at B comes out to be 16.42 liters. That means option C and D both are correct, and option A and B both are incorrect. Right? So I hope you understand this problem. This is basically a thermodynamic based problem which is graph based. We'll try to solve few more problems regarding the graph based in thermodynamics, and for such problems, stay tuned. Have a good day.